Hey guys, for this video we're going to build on the concepts that we picked up in the last video, and we're going to use them in a worked example with an inclined plane. So let's have a look at one. Right, so we've got an example here. A 75 kilogram box is on a 28-degree incline. The coefficient of friction between the box and the incline is 0.2. A small boy is applying a force up the incline on the box. If the box is accelerating down the incline at 1.34 meters per second squared, how much force is the small boy providing? Right, so you can start to see a lot of the tools we picked up, such as friction, normal forces, now inclined planes, they're all coming into play at the same time. So things are starting to get a little bit more complicated. Right, so I've drawn basically what this looks like, a block on an inclined plane, the force of the boy pulling the box up the plane. Let's draw a few more things. Right, we know the weight force goes straight down. I'm going to draw that big so it's nice and neat. And the normal force goes perpendicular to the plane. Right, so that's the normal force. This is the weight force. So like we did before, I guess there's also a friction force going in this direction. We'll just put that in. It's not really too necessary right now, but we'll put that in. Let's replace the gravity with its components. So there'll be one going straight down the plane. We're going to do the x direction as that. We'll call this part fx. And there'll be one perpendicular to that, like it'll be there, but I'm actually just going to draw it. I'm going to move it here so it's opposite to the normal force. Alright, and we'll call that Fy. Cool. So that's our diagram. They do get a bit messy, so draw them quite big. I'm going to move the triangle, the gravity triangle, to down here. So let's draw that. So gravity goes straight down, the weight force. This way, we'll call it Fx, and down there, call it Fy. That doesn't look like a very good right angle, but that's actually where the right angle is supposed to be. Cool, and the angle between Fx and Fy, if you'll remember, asked you to prove it as an exercise, this is actually 28 degrees, just like the angle in the plane, which I just read off the question, is 28 degrees. Yeah, so this angle in here is also 28 degrees. Right, let's leave that diagram. It's getting a bit too messy. Alright, so we're going to look at sine 28 degrees and see what expressions we come up with. It equals Fx over Fg. Right, so that leaves us with Fx equals the weight force times sine 28. I'm just going to leave that weight force out for a second, because we know that the weight force is actually equal to the mass of the block times gravity. We've seen that quite a few times, and it won't be the last time we see it. Fy, by a similar process, you'll find equals cos mg cos 28 degrees. Right, so we've got our values for Fx and Fy. Now, how do we use them? Right, so we've got our values there, written there. Now, from the diagram and from our concepts, the normal force ended up being opposite to the y component of the gravity force. Now, because that's in equilibrium, because the block's not flying off the plane, those two forces must be equal and balanced, right? We also have that the frictional force, we have an expression for that from a previous video. Now the block's moving, so that's kinetic friction. And we know that the normal force is equal to Fy, which from here we can just sub in UKMG cos 28 degrees. Now I'm going to leave the numbers out till the very end because that's what causes a lot of mistakes. Right, so we've got an expression for our friction force. And now let's move on. Let's have a look at this diagram over here and just try and conceptualize the problem once again. Right, so let's look at the x direction. It's not in equilibrium, so it's not so simple. The force pulling it down is gravity, or the weight force, but only the x component of the weight force, right? The forces pulling it back up in this direction are friction, opposing the motion, and the force that the buoy is applying to the box. Right, so if you just a refresher on the question, we're trying to find out how much force the small buoy is providing. Okay, so let's move on. I'm just going to write that in there. Okay, so the net force on the box, it's not zero because it's not in equilibrium, but it's actually, so it must be equal to the mass of the box times the acceleration of the box. Another expression we have for the net force is just to sum the forces. So we're going to say it's accelerating this direction, so we'll define downwards as positive. Right? And then these two forces are going in the opposite direction. Force of friction and force of the buoy. So that's another expression that we have. We have an expression for this at the top of the page. If you'll remember, fx equals mg sine 20, fgx equals mg sine 28. And we have expressions for these now, not for the buoy because that's what we're trying to find. So this one here, I'm going to start writing small, cos 28 degrees, that's just over there, plus the force that the buoy is applying. Right, now we can just rearrange a little bit. We can subtract, we can put the force of the buoy on this side and leave it as negative because it's negative over there, and we're going to just move these two things to that side. So we need to add this because it's minus on that side. This is also added because it was already on that side, and then we have to subtract that off both sides. Right, so now we've got an equation for the force of the buoy. We actually have all of these values just from the question, so let's put them in. UK was 0.2 times the mass of the box was 75 times gravity 9.8 times cos 28 plus the mass of the box, and it was accelerating at 1.34 meters per second minus the mass of the box times gravity times sine 28 degrees. Now I'm just going to type that all into the calculator, and if you times it by -1, you get the force that the buoy is providing is 114.8 newtons. So that's how we use inclined planes. That was quite a complicated problem. I hope it all made sense. Thanks, guys.